Hello students, welcome to classroom. In today's class, we will be continuing with what we have stopped in the previous video. In the previous video, we were discussing about image formation by spherical mirrors with respect to concave. Now we have learned the different cases. How many cases were there? In total, there were 6 cases. Okay, we have discussed all the 6 cases. Now we will proceed with the other type of mirror, which is convex mirror. So let us start the class. So in today's class, we will be studying the image formation by convex mirror. Now, unlike concave mirror, when it comes to convex mirror, there are only 2 cases. Okay, so we will study only 2 cases. Now, case 1. So the first one will be case 1. Now, we will be writing the exactly same thing how we studied concave mirror. So I will request you to grab your pencil or a pen and notebook and start writing down. Okay, make notes out of this. So you know what we do? We write the object position, then image position, then size, and finally we write the nature. Is it not? Now let us write the first case. There are only 2 cases, so we will first discuss the first case. In case 1, let's draw the ray diagram for case 1 for convex mirror. So now it's a convex mirror. So convex mirror, is this convex or concave? Okay, this is concave. Okay, so this is convex. Convex will be like this. Okay, convex will be like this. Okay, convex. So we will draw a convex mirror. So draw a convex mirror. This is convex mirror. Okay, this is the left side, this is the right side. Remember the left side. Okay, we will consider the left side. The left side will be the polished smooth surface, so the right side will be the back side. So you should do like this. Okay, to indicate the back side. Now time to draw the principal axis. So let's draw the principal axis. Remember class, this time you have to extend it, okay, to this side also, till here also. Why? Because this is a convex mirror. In convex mirror, the image will be formed here. Okay, will be formed here on this side. Okay, I hope we are not going to the end of the whiteboard. I hope not. So this is the pole, okay, and then we will consider 2 light rays. So let's consider 2 light rays. What is the name of this line? The name of this line is principal axis. Okay, so let's consider 2 light rays. So ray number 1 travels, we are following rule number 1. Okay, rule number 1. In rule 1, the ray travels parallel to the principal axis. Now this is a convex mirror. Okay, now how will the reflected ray go away? How will the reflected ray pass? Now the incident ray has already made contact with the mirror here, so this becomes the point of incidence. Now reflection will take place. So how will the reflected ray reflect back? So it will reflect back, okay, like this. So now draw the focus here, let the focus be here. So to draw the reflected ray, it has to be like this. Okay, so the reflected ray will go away like this. Let me like this. Okay, this is how the reflected ray will go. So incident ray goes, touches the mirror, and then it becomes now the reflected ray. The reflected ray is going away like this. Okay, now so we trace it back, and then okay, on tracing it back, it will go and hit the focus. Okay, so it is following the first condition, isn't it? Rule number 1. In rule number 1, the ray travels parallel and then it passes through focus. Since this is a virtual case, in convex mirror we are going to get virtual case. In all the virtual cases, okay, we have to trace it back. Okay, this is the only difference between concave and convex mirror. Drawing for concave is easy, okay, because concave mirrors, they give us real images, so the reflected rays, they actually do meet. But convex mirrors are not like so. So for convex mirror, you have to put some extra effort, okay, because they may be a little challenging in the beginning, but you will master it. Okay, I know you'll master it. Okay, you will. So next one, ray number 2, same thing. Okay, ray number 2 also is traveling parallel. Okay, traveling parallel. Okay, now before I forget, we forgot to discuss where the object is. Where is the object in case 1? Okay, in case 1, in terms of concave mirror, where was the object? The object was kept at, yes, infinity. So here also same thing. Okay, the case 1, the object is always kept at infinity. Okay, so object position, object at infinity. Okay, object is at infinity. Infinity symbol is like this. Okay. So the object is infinity. Okay, so the object infinity we are not going to draw. Object at infinity we don't draw. Okay, if you want you can draw dotted lines here to indicate that the light rays are coming from very far object. Okay, object at infinity means the object is far away. Okay, got it? Stars are at infinity. Okay, because the stars are very far from us. So if anybody asks you what is the position or how far is the star from us, you can always say infinity. They are at infinite distance from us. Okay, now ray number 1, even for the second ray we are using rule number 1. Okay, so ray travels parallel. You know what will happen? It will pass through focus. But remember, this is a convex mirror, so here the image will be virtual. So do that. Okay, so now it will pass through, it will appear like it is passed through focus. So it will go like this. Okay, this is the point of incidence. Right, so see here, these are the 2 incident rays, and then these are the reflected rays, and then where are they? Where do they appear to meet? They appear to meet at focus. So where is the image formed? Well, the image will be formed at here where the 2 reflected rays meet. Though here they appear to meet, still we'll consider this. So the image is formed at focus. So the image is formed at focus. So image position you will write at focus. Okay, it's at focus. Then size. What is the size of the image? Image size is point size. Remember, whether it's concave or convex, in both the mirrors, images from a focus is point size. Okay, it's the size of a point. So the answer is point size. Point size. Okay, and nature. What is the nature? Convex mirrors will always give you virtual images. Okay, so virtual. Okay, remember virtual. If you want to write, you can also write virtual plus erect. Okay, but remember it will be virtual. You can also you can only say virtual also, still correct. You can also put erect. Okay, still correct only, but don't forget to write virtual. If you just write erect, you will lose mark. Write virtual and erect, you get full mark. Just write virtual, still you get mark. If you write just erect, you will lose mark. Okay, now case 2. Now we go to case 2. So same thing, object position, then image position, then size, then nature. All right, now let's find them one by one. So let us draw the ray diagram. So we will draw another ray diagram again here. So let us draw the ray diagram here. Let me erase this. I hope you are taking down notes, students. So let us draw the mirror a little this side. Okay, now this is the convex mirror. Back side is shown here. Draw the principal axis like this. This is the pole. Okay, now where will the object be? Now in the second case, and this is also the final case, okay, for convex mirror, object will be anywhere in front of the mirror. So the object can be anywhere. Okay, unlike concave mirror, you don't have to study behind the curvature at C, between C and F. No. Okay, for convex mirror, anywhere in front of the mirror will do. So let the object stand anywhere. Okay, you don't need to know where it's, as long as it is in front of the mirror, it will do. So let the object stand anywhere in front of the mirror. So let us just draw the object somewhere here. So let us draw the object here. The object is here, in front of the mirror. So what will you write here? Object position, so easy, in front of the mirror. Okay, so in front of the mirror. Easy, na? In front of the mirror. Okay, because it's in front of the mirror only. So in front of the mirror. Okay, now we will use the rules. We will always use rule number 1. Okay, rule number 1 is our favorite. So rule number 1, ray travels parallel. Okay, So this is the incident ray traveling parallel to the principal axis. You all know what will happen after reflection. It will pass through focus. But remember, this is a convex mirror. So let us first find the focus here. So let's say the focus is here. Okay, so the focus is here. So then it will aim the focus. Okay, now the reflected ray will go somewhat like this. So this is how the reflector will go. Okay, the reflector will go like this. Okay, it appears to touch the focus. This is rule number 1, isn't it? Ray traveling parallel passes through focus. This is virtual, so the figure will look somewhat like this. Are we clear? All right, then we will have to draw one more ray. Okay, we only draw 2 rays. So where will I draw the second ray? Well, the second ray, for the second ray I will use rule number 3. Okay, let me use rule number 3. So let me use rule number 3. Now, how is rule number 3? In rule number 3, where do the ray enter? In rule number 3, the ray enters through center of curvature. So where will be my center of curvature? It will be here on the focus, or wherever, or on the focus side. Since the focus is here on the right side, we will consider the center of curvature on the right side. So you already know that. You know what I do? I will measure the distance between P and F, and the same I'll take it. Okay, so it will be, I'll extend a little bit like this. Okay, it may be going off the, but then I hope it's still visible. So this will be my C. Okay, so now the ray will aim at C. Okay, so the ray will aim at C. So the ray will aim at C, and remember, ray which enters through C back traces through C. That means it will pass back through C. So this is all now reflected ray only. Through dotted line will draw. Okay, like this. Okay, so enters through C. So and exits through C. Okay, 2 arrows pointing opposite to each other. Okay, the first arrow is indicating the direction that it's entering, it's aiming C, and the second arrow is indicating that it's exceeding through C. Okay, got it? So now, where do the 2 reflected rays meet? This is a virtual case, so they are not going to meet in real world, but they will meet. Okay, we'll have to back trace it, and then they will appear to meet. Where will they appear to meet? See here, the 2 reflected rays, they meet here, so they will appear to meet here. So this is a virtual image, so remember, dotted, and then your object is here. Okay, so the object is between P and F. So image position between P and F. Okay, are we clear? Okay, size, well, size, you can say diminish. Okay, size is diminished. Okay, small, small though, it's not very big. Okay, small, we don't write small, we write diminish. So you write here diminished. Size is not very big. Okay, it's diminished. Object is much taller than the image. The size of the object is bigger, the size of the image is smaller. In such a case, we write diminish. Okay, and then nature, it will be virtual. Okay, virtual in rec. So virtual plus erect. All right, so this is it. Okay, we have discussed the image formation cases by mirrors also. Okay, now we will discuss the uses of concave and convex mirror. Okay, this is also important. They have asked in exam. Okay, they have been asking in exam the uses of mirrors. So let us discuss the different uses of both types of mirror, concave as well as convex. All right, so now all right, so uses of, we'll first discuss the uses of which mirror should I discuss first? Uses of concave. Concave mirror. So now remember this class, that when I look, or remember this, that the image, okay, the image of an object appears bigger okay, in concave mirror, and the image of an object appears smaller in convex mirror. So concave mirror produces a magnified, a zoomed image. So if I bring this marker and place it in a concave mirror, the marker size may be this big. So see, compare the sizes, see, okay. It's just a rough assumption, may not be this big, but I'm just trying to give you a strong figure that the real size of the object is this, but the image may be bigger, okay. And when it is a convex mirror, then okay, if it is convex mirror, then the marker will appear very small, okay, will appear very small. And then besides the marker, we may even see the surroundings around the marker, okay. So what happens in convex mirror, we get a bigger field view, okay. So these things will be taken into consideration and while studying the uses. So their uses have been identified, understanding their properties, that concave mirror will give you a zoomed or a magnified image, and convex mirror will give you a smaller, okay, smaller image, thereby giving you a wider field view, okay. So let us discuss those. Let us discuss the uses of the mirrors now. So the first one is concave mirror. So concave mirror, where do you think, okay, where do you think concave mirrors are used? Where will this zoomed image be helpful for us? So concave mirrors, okay, they are used in they are used as dentist mirror also, okay, dentist mirror, okay. Number B, they're used in torches, okay, they're used in torches, and number C, they're used in car headlights, okay, car headlights. Three will do, okay, these three will do. So let me just tell you some few things about this. So dentist mirror, okay, who is a dentist? A dentist, okay, is a doctor who checks your teeth, isn't it? So when you go to a dentist, suppose you have a cavity in your tooth and then you go to a dentist, so the dentist will tell you to open your mouth, and then the dentist will use a kind of a spoon. It's not a spoon, okay, but it will be like the size of a spoon, where a small mirror will be attached to it, and then as you open your mouth, the doctor will examine, okay, the doctor will examine your tooth, okay, by inserting that that spoon like, okay, object inside your mouth, okay. Now why is he doing that? Why is the doctor doing that? So that the doctor can examine your tooth. Your teeth is small, so the doctor will see, okay, a zoomed image of the tooth inside your mouth with the help of the mirror, okay. And that's how the doctor will be able to diagnose your problem. He or she can pinpoint where the cavity is precisely, okay. So that's why, that is how concave mirrors are useful to the dentist, okay. Then torches, okay, torches, torchlight and all that, okay. Now in the villages and all that, or in the olden days, people used to nowadays we have cell phone. From the cell phone we use this flash, okay. But in the olden days, when cell phones were not there, people used to buy torches, okay, so that they can travel, they can walk at night, okay, to see the road. So torches, they had concave mirrors there, okay. Then car headlights, okay, car headlights, they have concave mirror. So 3 uses is enough, okay. Then uses of, now let's go to the next one, uses of convex mirror. Convex mirror. So uses of convex mirror, number A, very important use of convex mirror, used as a rear view mirror. Rear view mirror. What is this rear view mirror? See, next time you travel through a bus, okay, look at in front, and in front, between the just above the driver, you will see a mirror, okay, and the driver looks into that mirror to see, okay, to see the passengers, whether there are any empty seats or not, and whether the passenger is stepping down or climbing up, like that. So that is called rear view mirror. Rear means backside, so the driver, okay, he cannot be turning back, that will lead to accident, is not. So he will just look at the rear view to see, okay, the view behind him. So that is called rear view mirror. Now, besides the rear view mirror, vehicles also have side mirror, isn't it? Now, next to the steering wheel, near to the door, there is a mirror that is called side view mirror. So convex mirrors are used as side view mirror also. So used as side view mirror, side view mirror. Okay, this is very helpful for the driver. Okay, again, okay, he can use the, now both the rear view mirror and the side view mirrors are present in vehicles only. So the driver can, in order to see the passenger and also the traffic behind, he can use the rear view mirror, okay, or he can use the side view mirror, okay, which will help him again in seeing the traffic, okay, in seeing the traffic behind him, because he cannot be taking out his neck and looking out. That will cause accident. Okay, so the driver looks into the side view mirror to see the traffic behind him. Okay, so very important, and especially while taking reverse also, the driver can look into the side view mirror, which will help him or her do a good back drive or back driving also. Okay, then any other use of convex mirror? Rear view mirror, side view mirror, and yes, one more use as road reflectors. Now you must have seen, okay, in junctions, okay, in junctions like where 2 or 3 roads are there, especially where 3-4 roads. Junction means basically one road goes to the left, the other to the north, to the south, to the east, like that. Okay, those are called junctions. So there will be, from the center point, there will be 4 roads or maybe 5 roads also. So those are called junctions. So you must have seen in junctions, okay, or in turnings, okay, a kind of a mirror which has got a bulgy surface. What type of mirror is that? That is a convex mirror. Okay, so that is a convex mirror, and that is used as a road reflector. Basically, it is kept there because it produces a convex mirrors. They produce a wider field view. Okay, so the driver can look into the mirror and then know whether a vehicle is coming or not, or whether there are any objects or obstacles along the path or not. So these are helpful because for the driver, because it helps the driver, okay, avoid accidents and mishaps. So it is important for the driver. And then we use convex mirror there because convex mirrors, like I said earlier, they produce a wider field view. Okay, so they produce a wider field view, thereby you can see so much, okay, so much in a convex mirror. The images may be small, but still then you can see behind you also. If you go and stand near a concave mirror, okay, your face itself may cover up the entire mirror, okay, because concave mirrors, they produce a magnified image. If you go and stand near a convex mirror, your image will be very small, and behind you, okay, behind you, even the other stuffs behind you will be visible, maybe, okay, so like that. So convex mirrors, they give you a wider field view, whereas concave mirror, they give you a magnified field view. Since convex mirrors, they give us a wider field view, we use them as rear view mirror, side view mirror, and at the same time as road reflectors. All right, so these are the uses of both the types of mirror. Okay, important for your exam. In exam, they may ask any one or any two, so at least you have to know, okay, 2 or 3. So that's it. I will end the video from here today. So thank you all for joining in and studying. Okay, keep studying. Okay, pray to God. God will definitely help you, but you have to do your part, which is study. Okay, study, and you will be bringing good marks in your tests and in your exam. Thank you all. God bless you all.